Now we consider so-called man-in-the-middle attack. The idea of such a man-in-the-middle attack is that an attacker tries to get a position in between the two communication partners. But he tries to get this position in such a way that he can see all the communication from the both partners, but the communication partners are not aware that there is someone, the attacker, in the middle. So mostly such man-in-the-middle attack remain unnoticed. We speak of transparency for the users by the affected communication partners, and that makes such kind of attacks difficult and dangerous. There are various different types of such man-in-the-middle attacks, which run at different level of various communication protocols and service. For example, we know man-in-the-middle attacks on the domain name system and on the application level. We know man-in-the-middle attacks on the SSL TLS secure socket layer level, on HTTP hypertext transfer protocol level, and also on the display of web pages in the web browsers. So let's have a closer look to such man-in-the-middle attack. Here are the two communication partners, A and B. They communicate with each other. For example, B is sending something to the communication partner A, but in reality, without that B becomes aware of that, the message is sent over the attacker, and the attacker can read the message, can manipulate the message, and then he forwards the message to the communication partner A with a spoofed sender address. So the two partners are not aware that there is a man or a woman, an attacker, in the middle. Let's look to such kind of attacks on the various protocol levels. Let's start with so-called DNS domain name server man-in-the-middle attack. To remind you, DNS, the domain name system, this associated the names, the domain names with the IP addresses. So if for humans it's easier to work with domain names instead of the complicated internet addresses, so the domain name system associates the name and the IP address for the communication. Now the idea of the DNS man-in-the-middle attack is that the attacker manipulates this DNS table. So he manipulates the association of a domain name to an IP address. So he tries to connect the domain name of a user of the communication by its own, the association between the domain name and the IP address of the user, by replacing the user's IP address by its own IP address. So, and for that, everyone who sends an information, a mail or a message to the user with the domain name of the user, then because of this wrong association, the mail or the message is forwarded to the attacker. So with DNS man-in-the-middle attack, an attacker ensures that the victim's domain name is assigned to his or her own IP address, and in consequence all the messages to the victim's domain name are delivered to the attacker. So a concrete attack scenario looks as follows. An attacker performs a DNS spoofing with the victim's domain name. So all data packets which are sent to the victim domain are then delivered to the attacker's IP address. The attacker reads the message or manipulates the data and then forwards the data to the victim's real IP address. The attacker knows this, so that the victim is not, typically it not becomes aware that the message did not directly come from the other partner. Another man-in-the-middle attack is on the browser level, the man-in-the-browser attack. The man-in-the-browser attack puts the malicious program in the browser, manipulating the view of web pages and capturing input data. So it is a particular form of a man-in-the-middle attack at the application level. Domain name system, HTTP, web are on the application level, and a very widespread functionality in many Trojans, especially in banking Trojans, comes with such an idea. So the famous Zeus or SpyEye or Carburb, these are Trojans with exactly that functionality, that they show something different than what's expected. Man-in-the-middle attacks are also possible on the SSL-TLS level. On the TSF level, this was the security level for the communication in the internet. So it was above of the transport layer and provides the possibility to encrypt all what's going there. So it is a security level. So a particular problem that affects the SSL-TLS security layer, which is responsible for the end-to-end encryption and also for secure authentication, is this SSL-TLS attack. The user of a previously established man-in-the-middle position on the lower protocol level, for example, by means of such an DNS man-in-the-middle attack, this is what the attacker misuse. So SSL-TLS enables communication partners to remind you to identify themselves through digital certificates. This digital certificates, which help to authenticate a user, makes it difficult for an attacker to perform such a man-in-the-middle attack. But attackers also find ways to deal with this difficult. The man-in-the-middle attack on this SSL-TLS level works only in case of configuration errors in the SSL-TLS connection. And it works only if humans are careless when accepting, for example, fake certificates. Let's have a closer look on this very dangerous SSL-TLS man-in-the-middle attack. An attacker creates a fake digital certificate named bank.com. The difference to the real bank.com certificate is that this fake certificate is not signed due to the duplication, so because the name bank.com is already certified by a trustworthy body, so it's no possibility for the attacker to get the same name certified. So now it is on side of the victim. When the victim accepts such a fake certificate, even in case of a warning about the non-trustworthy certificate appears, then the attacker can perform such a man-in-the-middle attack on the SSL-TLS level. The typical warnings you can see if the website does not know a certificate, so if it's not signed by a trustworthy body, comes here, and I'm quite sure you have already seen it on your computer. And if you click it back and say you can continue, then the system works with the fake certificate, and the attacker can continue to perform the attack. If the user accepts such a fake attack, he or she then unwittingly uses the created encrypted connection to the attacker and not to the desired communication partner. In our case, there is no encrypted connection to the bank. There is in the consequence of accepting this this fake certificate, there is an encrypted connection to the attacker. Then the attacker builds a connection to on his side. He or she builds a connection to the real bank in order to pass communications on and to remain undetected. So the user is thinking to interact and communicate with the bank, with a real bank. And in the start, when such a connection is established, the connection is secured, an SSL/TLS connection is established, and for establishing such a connection, the certificate is needed, because both sides need to know who is a partner. And in the moment the user accepts the certificate of the attacker, then instead of the certificate of the bank, then the user communicates over the station of the attacker with the bank. And now all what the user is doing can be controlled, can be considered, can be manipulated by the attacker. And then to remain undetected, the attacker communicates with the bank and forwards some message, forwards the fake message, so that at the end the user has a feeling that he or she communicates directly with the bank. So the attacker is in the middle. So what are protection measures against such man-in-the-middle attacks? The problem is first that it's often difficult to discover such an attack. So most important countermeasures to prevent man-in-the-middle attack is this strong authentication, that it's really clear who is a partner. In case of accepting such a faked certificate, this strong authentication is not performed. So the man-in-the-middle attack could be performed. The strong authentication, there are different ways. A typical way is by means of the use of digital certificates. And in some cases, it's necessary that the user is very careful to consider who is communicating with me. We discussed already some other with faked websites or with other things. We already saw if the user is not aware, that it's not looking carefully who is a communication partner, then man-in-the-middle attacks are possible. Nonetheless, the SSL/TLS man-in-the-middle is also possible with certificates not verified by, is only possible with verified not by trustworthy agency. Have the certifications verified by a trustworthy third party, then it is difficult and the attacker cannot perform such a man-in-the-middle attack. It's also, as a counter measure, as a protection, necessary that one has a close attention of such certificate warnings. Do not say, I accept it, be careful, look clearly to the certificate before you give any kind of reactions. Then for operators, an additional protection measure against man-in-the-middle attacks is the use of static certificates. These are genuine certificates which are stored as the first communication. So first time, for example, registering at the bank, this is the certificate for all kind of interaction with the bank. Only such kind of certificate should be accepted. And then it's always compared with the newly delivered certificate, and if necessary, such a warning is sent, and then the user has to follow the warning, has to become aware that he or she should not accept such a faked wrestling. So these are only a few examples of this man-in-the-middle attacks. I hope the idea that the attacker tries to become a part of a even secured communication so that the users are unaware and the attacker can see all what they are doing and can even manipulate or delete this data.